This is Mathematics, November 2022, paper 2 of the NSC end of year exam. Question 9, Euclidean geometry. 9.1 starts with a proof. That side. Okay. Yay, easy marks. Proof in paper 2. So most proofs start with a construction. This one is prove the theorem that states, just make sure always that you're proving the right thing. So it wants the theorem that states that line from center of a circle bisects a chord is perpendicular to the chord. So we have to prove that line from center of a circle, that bisects the chord, which is AB, is also perpendicular. So we're proving that it's perpendicular. Okay. First step, a proof is always a construction. In this proof, we construct OA and OB. So you write this, construct OA and OB. Then we take these two triangles, the triangle this side and the other one, and we want to prove that they exactly equals. So we want to prove if they're exactly equals, they're going to be congruent. So we do our congruency proof, which is in triangle ADO and BDO. In those two triangles, we need 3 things for congruency. I'm going to go for side, side, side for this proof. So number 1 is that AO is equal to OB or BO. That's because they're both radii of the circle. Second fact, second side, is that OD is common. Common just means it is literally the same line. And the third thing is that AD is given that it's equal to DB. They're equal. That was given. So you can write that it was given. Therefore, in order now, our triangle ADO, now you choose the same order in the second triangle, is congruent. So perfectly equals is the equal sign with an extra. To triangle, if we started on A, we have to start on B, because that's the position. And then we go to D, because that's what's common, and O. And because of side, side, side is our reason for congruency. Okay, we're not quite done. So far, we've proved congruency. So the next thing, we say that ADB is a straight line. Therefore, angle D1 is going to be equal to angle D2. But it's not actually therefore, let's just erase this. Angle D1 is equal to angle D2, and this is because of the congruency. We know this because of our triangle ADO is perfectly equals in every way, including angles and sides, to triangle BDO. So we've proved this already. So those 2 pieces of information, if it's a straight line, so just right on the side, not part of your proof, but if it's a straight line, then the angle is 180. And then if you halve that straight line, both of those angles are going to be 90 each. Okay. So last part of the proof, because those 2 angles are 90 degrees, we can say that OB is perpendicular to AB. And that's because of angles on a straight line. are equal to 180 degrees. And that's your, you want to write it a bit faster, but that's your quick proof for question for this exam. Question 9.1. Question 9.2. Going through the information, E, B, F, and P. Okay, so it's listing all the points on the circle with the center of O. So O is the center. GB is a tangent, GB. So I just usually draw the line like that and write tangent. Oh, that went out of my screen. So let's, well, tangent, that's a tangent. It's a tangent to the circle. So we have tangent here and here for the tan chord theorem. What else is given? FE is produced, which produced just means straight line. Every time you see the word produced is straight line. So FE is produced to G. So that's FEG is a straight line. OT is drawn such that T is the midpoint. So it cuts EF in half. GO and BO are drawn. BO. And where's my G? Here. Okay. BS is drawn through T. BS is drawn through T. And we have that causes a parallel. So let's take, where are our parallel lines? Parallel lines here. This is parallel to this. All right, that's all the information. So prove with reasons 9.2.1 that OTBG is a cyclic quad. OTBG is a cyclic quad. So let's find O, T, B, G. So we want this blue shape to be a cyclic quad. Now, 3 ways to prove a cyclic quad. Either the angle subtended by equal arc or equal chord AB. So the chord is there. If it was an arc, this will equal this. Then it's a cyclic quad. The other way is external angle of the cyclic quad. This needs to be a straight line. So this angle, the exterior angle of the cyclic quad, if you go along these 2 lines, you find the angle that doesn't touch either of those lines. That's the opposite interior angle. And they will be equal to each other. And the third way to prove a cyclic quad is if you have a cyclic quad, then the opposite angles add up to 180. So X plus Y will be equal 180, or A plus B will equal 180. Those are the 3 ways that we can do it. We're going to use one of those proofs. We just clean that up a little bit to start looking at what we know. What we know is that GBO over here must be 90 degrees. That's because OB is a radius. Okay. So when I look at this, I think to myself, well, it's probably not going to be, it might be the butterfly one, the one with the 2 angles equaling each other. It might be this one, or it might be an exterior angle. So far it could be any of them. We're going for the, we need, if this was a butterfly situation, then we'd need one other angle to be equal to 90 degrees inside here that is subtended by the same chord. So it's, let's take a look at what chord subtended that 90-degree angle. Well, it was subtended by OG. So it goes from there to OG. And I can see that OG actually does subtend another chord inside that shape, the blue shape, and that would be here. OG sub, the chord OG, excuse me, subtends to the point T as well. So if we can prove our RTP, what we need to prove is that T equals 90 degrees. Then by T is GTO. So if we can prove that GTO is 90 degrees, then we have finished up. We just have to write it up, but we've proved everything we need. And straight away I can see, well, this is the center and that cuts EF in half. And we just did the proof that that would cut, if it cuts the midpoint of a chord, it must cut it at 90 degrees. So we already know. So let's get this all written up. Number 9.2.1. Okay, what did we say? We said that GBO is equal to 90 degrees. And that's because the tangent GBO here is 90 degrees. Tangent is perpendicular to radius. Furthermore, we know that OTG is also equal to 90 degrees, and that's because of line from center to midpoint of the chord. It's line from center to midpoint chord is at 90 degrees. Therefore, OTG is equal to GBO. They're both 90 degrees, so they're equal to each other. And there we've proved our cyclic quad. You just need to write it out. BG is a cyclic quad. And the reason for the cyclic quad is that the angles were subtended by the equal line are equal. Good. 9.2.2. Prove that GOB is equal to S. Prove that GOB is equal to S. So we have GOB, GOB here is equal to angle S. Okay. Well, let's just get this a little bit cleaned up. 9.2.2. GOB equal to S. All right, I tried to fill in all the information I know so far. Just highlighted the parallel lines as well. So looking at, we want to somehow get the angle S to the angle GOB. So, well, S is equal to STF because of the parallel lines. It's an alternate angles situation. And ETB over here must also be equal to STF because of vertically opposite angles. Okay. So maybe let's see, what else do we have here? So we're nearly there. So probably something to do with the cyclic quad. All right, let's see. So this, I wonder if the line GB subtends, or it subtends to there, and it also subtends to there. So those are equal. So we've cracked it. Now we need to just follow our proof down on paper. So the first thing we said was that our angle S, there we go, is equal to our angle STF. And the reason for that was alternate angles, alt angles, and you need to name your parallel lines. So PS is parallel to GF. Okay. Then after that, ETB is also equal to STF. And the reason is just vert op angles. Then what was my last? GTB. Why did I say ETB? Oh, ETB. Okay, if we made this a G, it would probably be a little bit clearer. GTB and ETB are the same thing. So GTB is equal to GOT. GOB, excuse me. And that was because of cyclic quad D, cyclic quad, no, BTOG. BTOG and angles subtended by equal chord. Probably you can write one of these proofs. I just want to write both to be thorough. So those are equal to each other. And of course, then we can deduce that our first angle is equal to the one we were aiming for. So the last bit of the proof is that angle S is equal to GOB, which was what was required. That concludes question 9.2.2 and also question 9 of the November 22 NSC paper.